So in 43 it says, which graph shows the motion of a heavy steel ball falling from a height of 2 meters? So we have only a very small height, which is 2 meter, and this height might maybe traveled by the ball in hardly 1 or 2 seconds, no, less than 1 second, because when an object falls, its speed is 9. Initially its speed increases from 0 to 10 in only 1 second. So you can say, suppose the ball falls. Here is a ball, suppose, and its length is 2 meter. When it falls by through 2 meter, it will hardly take 1 second. The time would be less than 1 second. So during this time, you can see like distance is increasing with the distance increases, but with every interval the increase in distance would be something like non-uniform. Like for the first second, maybe 10 meter distance is traveled, for the next second it would increase, but the change in speed would remain same. So that's why the given option, out of these given options, the speed is uniform because it is under the influence of gravity. So this option is incorrect. And this portion of the graph, if you just observe this one, like it's okay till here, but it after this point it says that the object would be in state of rest. That makes it wrong. So that's why I'm gonna cross this one. So this option is also incorrect. So as far as the option C is concerned, you can see it says the distance is uniformly increased. So in reality, when there is a when object falls, its distance time or position time graph would be, frankly speaking, like this. So that's why it's cross. So we are left with only one option, which is correct one. So actually you know that the gradient of speed time graph is acceleration so okay, so actually if we calculate the gradient of speed time graph, it will give us acceleration, and acceleration in this case when an object falls is gravitational acceleration. So that's why gravitational acceleration is a uniform acceleration. That's why its graph would be something like this. Okay, let's move to the next one. In 44 it says uh, okay, the mass of the wood, okay, see here, the mass of the wood is 2 kg, is pushed along the horizontal flat surface of a bench. The friction force is, this is the friction force, which is 4 Newton acting on it. When the block is pushed along the bench with a force of 10 Newton, okay, we have a force of 10 Newton here, it moves with a constant velocity. Okay, so you can say applied force minus friction force is equal to resultant force. Okay, so you are applying 10 Newton force and friction force is 4 Newton, and the resultant force is mass into acceleration. So 10 minus 4 is 6, which is equal to mass is 2 kg times acceleration. So 6 over 2 would be your acceleration. So you can say acceleration is 3 meters per second square. So the object will actually this wooden box or whatever is there will move with the acceleration of 3 meter per second square. So okay, speed is 3 meter per second square, that's 3 meter per second, that's wrong. Speed is 5 meter per second, that's wrong. Acceleration is 5 meter per second, that's wrong. And we have only this option. In 45 it says a diagram shows a strip of paper tape that has been pulled under a vibrating arm by an object moving at a constant speed. The arm was vibrating regularly, making 50 dots per second. Okay, here is something 50 dots per second. Okay, we have little information about the length of two dots. See, it says from here to here it is 20 centimeters. So let's count the number of dots in 20 centimeters. Then we can convert these 50 dots into some in terms of length. We can convert these 50 dots in length. So suppose this is our 0 position, 1 2 3 4 5 6 7 8 9 and 10. There are 10 dots and we have a length of 20 centimeters. It means 20 is the length and there are 10 dots. It means each dot carries 2 centimeter length. Okay, so each dot carries 2 centimeter length, and how many dots are printed in 1 second? So you can see here it says 50 dots per second. So it means we can convert the number of dots into length. So now we have 50 dots, each of length 2 centimeter is actually 100 centimeter length. 100 centimeter is equal to 1 meters. And how much it takes time? It takes only 1 second. So it means the speed is 100 centimeter per second or 1 meter per second. 100 centimeter per second or 1 meter per second. So the options are, it is 2 centimeter per second, 5 centimeter per second, 200 centimeter per second. These are the incorrect options and we have only one correct option, which is 100 centimeters per second. Okay, let's move to next one. The diagram shows a coil in magnetic field. So in case of a DC motor, at this point, like it's a little early to tell about the DC motor, because it is part of electricity and magnetism, which is like 4 to 5 like almost 10 chapters away from this topic. So at X and Y, in case of DC motor, here is a DC motor mentioned, like you can see DC motor is mentioned here. So in case of DC motor, there are split rings. Split rings, we will learn about split rings in electricity, but right now just consider that it's a split ring. You can search out what is split ring. Okay, so split ring is then connected with the DC supply. So currently at X and Y position, we can expect split rings commutators. Okay, next is 47. Which graph represents the motion of a body falling vertically that reaches the terminal velocity? Terminal velocity, we know that it's a constant velocity. So when an object falls, its initial speed is 0. With the passage of time, its velocity or speed increases, and then it becomes constant when it reaches terminal velocity. So look at the graph in case of A. It says initially it has maximum speed, then with the passage of time its speed is decreasing. That's wrong, because initially the speed of the falling object is 0. Or look at the C part. It says initially the speed is very high, with the passage of time its speed decreases and comes to 0. That's wrong. Look at the D part. It says initially its speed in little increases, then it shoots to an infinite speed. So all these things are just wrong. You'll just mark them across. Okay, we are left with only B option, which is correct option. Let's discuss why it's correct. You can see initially the speed of the object increases, and after certain time, when weight of the object and drag force becomes equal, it gains constant speed. So that's why it's correct. Okay, let's see the 48th one. It says a car takes 1 hour to travel 100 kilometers along the main road, so and half hour to travel 20 kilometers along the side road. So it means the car takes like suppose this is 100 kilometer and the car takes 1 hour to complete this distance. This is a side road which is approximately 20 kilometer, and this distance is traveled by the car in half hour. So it means let's calculate the total distance. So you can see the total distance traveled by the object is, total distance is 100 plus 20. So total distance is 120 kilometers. Okay, now how much time is taken? So first is 1 hour, then it is 0.5 hour for the next distance. So we have total 1.5 hours time. So for average velocity, we know that the formula is total distance over total time. So average velocity is total distance is over total time. So what is the total distance? Total distance is 120 kilometers and discovered in 1.5 hours. So our answer is 120 over 1.5 hour is 80. So the correct option is 60 is incorrect, 70 is incorrect, 100 is incorrect. So we have 80 here, which is a correct option. Okay, in case of 49, you can see what must change when an object is accelerating. You know that for an accelerating body, like, the velocity of the object must change. So for velocity, is there any oh yeah, here is a velocity. So for an accelerating body, uh, the the mass is a constant thing. It wouldn't change. Speed has no, like, speed is a scalar quantity. Force acting on the body. Okay. So when a body is what must change when a body accelerates is accelerating, its velocity must change. Okay. The next is the graph illustrates the okay, now 50 number. The graph illustrates the motion of the object. Which feature of the graph represents the distance traveled by the object while moving at a constant speed? We know that area under the graph is actually area under the graph tells us about the distance traveled by the object. So area under the graph is actually distance traveled and we know that the gradient of velocity time graph or speed time graph is tells us about acceleration. Okay. So which options are okay? Area of S, no, like, area of T, that's wrong. The gradient of point X, gradient will tell us the acceleration. So in order to calculate the total distance, we need to calculate the total area of the object. Okay, let's move to next one. Which quantity X is calculated using this equation? Just look at the question. Okay, suppose you people don't know about the, like, about the formula, so we can use the method to find out the formula, like the quantity is by units. Change in velocity, the unit of velocity is meter over second, and the time taken is also measured in second. So we have meter over second square, and the unit meter over second square is actually acceleration. So this quantity is actually, this formula is actually the formula of acceleration. So we can see speed wrong, distance traveled wrong, average velocity wrong, acceleration correct. '52. The graph shows the movement of a car over a period of 50 seconds. What was the distance traveled by the car while its speed was increasing? You can see the speed of the car is increasing during first 20 seconds. Like, till here the speed of the car is increasing. After that after this interval, you can see uh, the speed is constant here. During this interval the speed is constant, and from here to onward the speed is decreasing. So this is actually the total portion where the speed is increasing. Okay, if we calculate the area of this portion, this will tell us the distance traveled by the object. So let's calculate the actually area. This is actually triangle, so area of triangle is 1 over 2 base into height. So from 0 to 20 second, its base is 20, and height is 10. So you have 10 times 10 is 100. So distance traveled would be 100. So we have 4 options. You can see 10 meter is incorrect, 20 is wrong, 200 is wrong, and we are left with only one option, which is the correct option. Okay, let's move to next one. Okay, it says an object is falling under the influence under gravity with terminal velocity. Terminal velocity is a constant velocity, you people are well aware of. What is happening to its speed? Okay, let's look at the options. Okay, so you can see like we can say by definition, okay, when an object is moving with the falling under the gravity with terminal velocity is a constant velocity. Okay, then what will happen is what is happening to speed? What is the difference between speed and velocity? Like, for simplicity, you can say speed is actually the magnitude of velocity. The magnitude means a number, only a quantity, a fixed number. So whenever we are talking about the terminal velocity means a constant velocity or a fixed velocity. It means its magnitude is fixed. So it is decreasing. Oh, that's wrong. It is increasing. Wrong. It is increasing. Wrong. It is fixed. Actually the terminal velocity is fixed, means its magnitude is fixed. So the magnitude of terminal velocity is you can say speed. Now 54. Which of the following defines acceleration? You know that acceleration is rate of change of velocity. So change in velocity with time, change in distance. You can see it looks fine, because change in velocity with time taken is correct option. And let's see about change in speed. Actually acceleration is a vector quantity, so there should be a vector quantity. Like here it's a speed is a scalar quantity, so scalar quantity cannot generate change in scalar quantity results a scalar quantity. Change in distance over time, this is the formula for speed, not for acceleration. Change in distance in a fixed direction. Okay, change in distance in a fixed direction means it's a velocity. It's a displacement, and rate of change of displacement gives velocity, not acceleration. Change in distance, okay, in a fixed direction, it means distance with some direction is called displacement. So change in displacement, this term is actually change in displacement with time is velocity, not acceleration. Okay, let's move to 55. The graph shows the movement of a car over a period of 50 seconds. What is the distance traveled by the car during the time when it is moving with steady speed? Steady speed means constant speed. So let's see the graph. During this period from 0 till 20, the object, like the speed of the object is increasing. During this period, the speed is fixed. During this period, the speed is decreasing. So we are going to calculate the distance under this portion. Let me mark it. Okay. Okay, this is the portion. For this portion, you can see it's a rectangle. For rectangle, the base is 20 till 40, so you can say it's 20. 40 minus 20 is 20, and its height is from 0 to 10. It means its height is 10. So now you can calculate the area of a rectangle, which is length into height, or base into height, which is 20 into 10. 200 meters. So distance travel is 200 meters. Let's mark the wrong ones. Wrong, wrong, wrong. So we have only one correct option, that is this one. Okay, let's move to next one. Oh, done.